Hello class, this is Marcella again, and today we're going to be talking about disturbances. One of the big disturbances that's been getting a lot of press lately is fire, and fire not only in the lake states, but fire especially in the West, California, and Alaska. So there's been a lot of press on how fire is not only influencing our forest community, but also how it's impacting society with smoke and everything like that. So, what is a disturbance? A good definition, and we talked about this a little in the last lecture, is any relatively discrete event in time that disrupts ecosystem, community, or population structure and changes resources, substrate availability, or the physical environment. So, this is probably a good one. Don't need to memorize this definition, but this is a good definition that will likely show up on an exam. And what you should really key into is any relatively discrete event that disrupts structure and changes resources. So it's a discrete event, it's changing something, it's changing resources, and it's changing structure. So kind of key in on these these key parts of this definition. So discrete event, disrupting, changing. Because I may ask you to define what a disturbance is. And I'm not looking for something word for word, but really something that encompasses this idea of change and something that's discrete. So disturbance types. So this should be the one that has all these great pictures that really gets at, these charismatic pictures of forests and how forests change. So fire is a huge disturbance type that impacts forests. And fire is not consistent, so it's not the same in every forest type. It's not the same even within a forest type. You're going to have variation. So we see this map of historical natural fire regimes, and with the kind of blues and greens being pretty frequent, either low severity or high severity fires. And we can see, especially in this kind of prairie region, that's what we think of these oak savannas, these open prairies, even across this western part of Minnesota, these very low frequent or very high frequency, low severity fires, compared to something like these oranges and reds, with the reds especially, very infrequent fire regime, but very severe, stand replacing. And we can see where some of these higher fire return intervals are generally forests where we don't think of fires occurring often. So in the northern Wisconsin, upper peninsula of Michigan, some of those high return intervals could be in northern hardwood forests or other systems. And we see that kind of in Maine and parts of New York. So we have this range of variability. And this variability includes everything from stand replacing, very destructive fires, to surface fires, which are, you may not even be able to tell that a fire went through here a year later. So what's involved in fire? So the fire triangle. And this is something, especially if you get your red card, if you work on fires, this is something that you're going to take a few hours, if not, well, I think it's a 5-day class. Yeah, I think. So your red card, it's like a 5-day class where you're going to go into a lot of detail on fire and its impacts and how it works. So the fire triangle, you have 3 factors, which includes oxygen, heat, and fuel. And so you need those 3 factors for a fire to start. So if you remove any of those factors, oxygen, heat, or fuel, you're not going to get a fire. And then once you have a fire, topography, fuel, and weather really impacts what kind of influence this fire is going to have. So whether you're talking about flat slopes or aspects, which aspect you're on, the weather, if it's windy, if how low the relative humidity is, and the fuel. So is it moist or is it dry? These are all going to impact your fire behavior. So there's a difference between the fire behavior, how the fire acts, compared to what is necessary to start a fire: oxygen, heat, and fuel. So fires create this mosaic of conditions, and this mosaic of conditions occurs even within fires from in stand replacing fires and low severity fires. You're going to have a mosaic of conditions, and that mosaic of conditions includes everything from unburned patches to areas that are severely burned. And that mosaic of condition is going to influence a lot of factors, including how the soil, this change in soil conditions. So the nutrients, the microorganisms, it's going to vary based on whether it was a severe burn to unburned. So what's going on is really going to be impacted by these microsite variabilities. We also can talk about some definitions of fire. So we have two that I've kind of been using already in this lecture, and one of them is fire severity, which is the rate of heat release for an entire fire at a specific point in time. So it's the release of heat. Whereas fire severity is the degree to which a site has been altered or disrupted by fire. It's a product of fire intensity, fuel consumption, and residence time. So we can see there's a difference in when we talk about fire intensity and fire severity. Another disturbance type is wind, and this is an example of the 1999 blowdown in northern Minnesota on the Superior National Forest and the Boundary Water Canoe area. So wind, what does it do? Well, it uproots or snaps trees, so it impacts the structure of the tree. And a tree can build up resistance to wind when we look at the prevailing direction. So in certain areas where it's very windy, such as on top of mountains or areas that have a lot of wind, you can see flagging. In this example, you can kind of see some of these trees have more of their leaf area, more live branches on one side of the tree compared to the other. And so that's where you can tell which way the wind predominantly comes from. And these trees have built up a resistance to that wind. So susceptibility. So older stands are generally more susceptible to wind damage. Also after some kind of forest management activity. So when we were talking in the last lecture about this edge effect, so those stands right on the edge can be impacted by wind, especially if they were relatively dense and you open the stand up, you can get some wind damage. Disease, and that could be either stem or root rot, and again, trees at the edge of the stand. So what does wind do? Well, just like any of these disturbances, it impacts growing space. It impacts the availability. So growing space will be variable. So it will change. The amount of growing space opened up will vary based on whether it was a huge windstorm versus the removal of an individual tree or maybe part of a tree. It also creates this pit and mound topography. And this pit and mound topography can be pretty important for certain species regeneration requirements. So the uprooting of a tree allows mineral soil to be, allows this upturning of mineral soil. So there's a very different environment, soil environment, in this in the area over here compared to this mineral soil over here. So you have leaf litter, you have interactions with understory plants, and this uprooting has created a different kind of microsite, and that microsite can be very important to certain tree species. Another big one that we can see are floods, erosion, siltations, and landslides. So basically, this is the movement of soil. So somehow changing our soil environment with due to water or due to some other event. So let's get into what each of these are. So flooding, that's a pretty obvious one. Heavy rainfall or snowmelt. And flooding can cause a lot of these other impacts. So erosion is when water moves rapidly over the soil surface, gaining momentum as it flows downhill. So erosion can be the movement of soil, the movement of other aspects such as down dead wood or rocks or whatever, the movement off a site. And then siltation is the deposition of fine soil material by water and wind. And then landslide is the bigger form, probably one of the biggest ones, the sudden translocation of soil material from a higher or lower place under the direct influence of gravity. So the landslide is the one that generally gets a lot of press in the news, such as in areas, especially of mountainous areas, you can get these landslides being impacted where you have this huge movement of soil and other particles. So floods and erosion. So this is an example of the recent flooding. I believe that's up in Duluth, and you can see just this huge impact of water. And we talked about how water is required for trees. So it's one of those required nutrients. So trees need water. Water is one thing that impacts growing space, what's available to the tree. But too much water, as we saw, can starve a plant. So it removes oxygen, and trees that aren't adapted to these high water tables can have negative influence, can be negatively impacted. So erosion can be due to a few things, so including poor management practice. And here's just a few really broad examples. These are not the only things that influence erosion. So in the southeast, we have possibly poor farming practices. In the Rocky Mountains, we have overgrazing. And in the Pacific Northwest, we have forestry practices. And as a natural resource manager, forestry practices in the Pacific Northwest, that's where a lot of public press has gone to. And it's also increased some public policies, which has been really good in maintaining good, sustainable ecosystems. So when you think of erosion, what you should be thinking is the loss of soil equals probably the loss of nutrients. And that will change the amount of growing space. That can impact your growing space and what's there now, and not only now, but what can be there in the future. So siltation often occurs with flooding, so it's that movement of fine particles, and this can be positive or negative depending on the species. And then finally, landslides. So these are the huge movements of particles, of soil, of everything, and you can see this change in the landscape, in the ecosystem, is going to have long-lasting impacts. So this completely will change the vegetation that's here, that's able to be here now, not only now to revegetate this area, but also in the future. So with this, you also have to worry about not only what happened, but what could happen again. So the loss of more of that soil due to erosion with other precipitation events. So, one that we don't have that's not extremely common in our neck of the woods in the lake states are avalanches. However, this area was heavily impacted by past glacier activity. So, avalanches is the movement of snow either as loose snow or slabs of snow. And these avalanches break trees and create these zones. So, it creates these zones of kind of short, shrubby areas, and generally something that's a pretty low, is a high severity disturbance, but generally occurs only in a very small set of circumstances. Glacier, kind of opposite of this, it's this broad impact, so its influence, past glacier history has influenced much of the northern US and Canada. So it's influenced not only the soils, but also the species distribution, so why species are where they are. And one species that can be a good example of that is eastern hemlock. So the glaciers came, it covered most of Minnesota, Wisconsin, the Upper Peninsula of Michigan, and we see eastern hemlock is present in just a very small portion of Minnesota, but it's present throughout Wisconsin and Michigan. And some thought is that eastern hemlock is still migrating. So we're seeing that these impacts of glaciers have a huge influence on species distribution. So disturbance types, another one, volcanoes. So a good example is the 1980s eruption of Mount St. Helens. So we've had 30 years of recovery. So volcanoes is not something I'm an expert on. So I'm not an expert on how volcanoes shape the forest system. But what some scientists are seeing is that after a volcano, there is this recovery. There is this life that comes back. And it's different. There's a lot of aspects that are different because of this disturbance. So one that does happen in this neck of the woods, ice storms. So ice storms are when warm, moist air produces rain, which then falls into a sub-freezing air layer at the ground layer and coats everything. So this is extremely variable, and it can range from breaking individual branches to breaking whole trees. And even if it just breaks a few individual branches, what these small breaks can do is introduce pathogens. So disturbances are often interacting. There's often some kind of, there's multiple things usually going on. So it's not just one disturbance. They kind of interact, they kind of build off of each other. They do happen at discrete times, but there is an interaction. Mammals. So mammals are a big impact on our forest. They eat lots of things, including trees. They graze trees, browsing them. So deer browse is a huge impact when we talk about our forests of not only the lake states but the Northeast. So a lot of work goes into protecting these young regenerating individuals. So the Minnesota DNR spends an enormous amount of time and money to put on bud caps. And a bud cap is exactly what it sounds like. It's a cap used to protect the leader, the bud, from being nipped off by being browsed by deer or other animals. They eat seeds, and they also cause physical damage. So porcupines this is an example of a lodgepole pine where a porcupine has done this damage. So what they do is they basically girdle the tree. So they remove that ability to transport nutrients, to transport water, and the tree starves. They also influence composition. So grazers, any kind of animal, if they are selective, and most are, on what they prefer to eat, that's going to influence not only our overstory, but also our herbaceous, our shrub layer. Also, a big one is insects and diseases. So insects and diseases include both native and invasive species, and they can have a huge influence on stand structure, composition, and history. So this is an example again from out west with lodgepole pine and mountain pine beetle. A big one that will be influencing stand structure, composition, and history in the lake states, especially in Minnesota, is emerald ash borer. So Minnesota has a huge amount of ash trees, of ash resource, and the emerald ash borer could really impact stand structure, composition, and history. And one group for their reading assignment will be reading about simulating emerald ash borer mortality in Minnesota. So final one, and this one is climate change and disturbance. So climate change is not a discrete event. It's this event that's kind of occurring continuously, right? We have changing climatic conditions, and we see these changing climate. When we're talking about climate, we're talking about long-term trends in weather. So that's 30 years at least we're talking about. So these are long-term trends. But this influence of climate change impacts disturbance, impacts these discrete events. So we see changes in temperature and precipitation, and that can influence growth factors. So by increasing temperature or decreasing precipitation, we can have trees that are more stressed, and that stress may increase the potential for a disturbance, an insect outbreak, a fire, all these kinds of things. There's still a lot of questions on what this is going to do, what are the impacts, and these impacts could be potentially novel. So we may be seeing things that we might not have expected or weren't common in the past that may become more common in the future. And this little diagram kind of summarizes this as temperature gets warmer and precipitation gets drier. We have this drought duration, so that gets longer and drought intensity gets higher. So we're seeing this impact, this shift in what's available. So what's all those key nutrients, all those key elements for tree growth are changing. And that can change how species respond to disturbances. So when we talk about how trees are allocating resources, so if they have less resources to allocate, they may not be able to allocate as much resources to these defenses, to defending themselves against insects, against diseases, against other outbreaks. So again, still a lot of questions, but something to kind of keep in your back of your mind. So that is the end of this lecture on disturbance. Thanks.